So today, my future of tomorrow, you're going to learn how to understand and apply function notation. You're going to learn how to categorize functions using the characteristics of their equations or graphs. Kind of like I can categorize you guys in here, right? And group you guys based on your height, your hair color. You can group functions in a similar way. We're also talking about something called domain and range, and you should be able to tell me what the domain and range of a function is by the end of the day. Okay? All right, so I believe this is printed for you. So let's begin the lesson. All right, a function is an equation that generates one answer for every input. So I'm going to make an x and y table here. Let's plug in a number for x. If I were to plug 0 here for x, what would I get for y? Yeah, the square root of 0 is 0. What if I were to plug in 1 for x? I would get 1 for y. Now I could plug in 2. I don't want it. But you could get your calculator out and push the square root of 2, and you get something weird like 1.41. So I'm going to skip 2, and I'm going to skip 3, and I'm going to plug in 4, because 4 has a nice answer. What would I get if I plug in 4 here? 2. Okay? Well, all of these are points, right? This is the point 0, 0. This is the point 1, 1, and this is the point 4, 2. But on a graph. So let's go ahead and do that. We have 0, 0, right? We have 1, 1. And then we have 4, 2. So far it looks like that. And it will just continue looking like that. So there's 3 different ways to represent a function. One way we can represent a function is with the equation, right? Another way is you can make a table of values that can show you specific points that exist for that function. The third way that we can represent functions is with a graph. Okay? They all serve a different purpose. Equations are really good for calculations. Graphs are really useful whenever you're trying to get a big picture of what all the possible outcomes are. Tables are really just kind of useful for connecting the two, really. They don't really serve much more of a purpose than that. But a function is an equation. Do you guys agree this is an equation? Yeah. So a function is an equation that generates one answer for every number we plug in. When I plugged in 0, how many answers did I get out? 1. I got 1. When I plugged in 1, how many answers did I get out? 1. Every time you plug in a number, you get one answer out. That makes a function. Okay? So that particular equation over there happens to be a function. You guys good? Yes, sir. And there's three ways to represent them. Okay. But not all equations are functions. Let me give you an example. If I were to plug in 1 for x, we have to solve for y. Does anyone know what the answer would be? 1 is true. But guess what else? -1 also. Don't you guys agree that +1 squared is 1? And -1 squared is 1? So when I plugged in a number, how many answers did I get? I got 2. Is that a function? That's not a function anymore. Okay? So anytime you plug a number in and you get out more than one answer, that's not a function. So why does it matter if something's a function or not? Well, I guess you could say it's not predictable then, right? A function is a nice thing where if we plug something in, we should be able to predict what the outcome's going to be. Well, if it's giving me different answers, then I can't predict. It's not a functional relationship, you could say. Okay? All right. So now, since not all equations are functions, only some are, then the ones that are functions get a special badge, right? Wouldn't it be kind of irritating to you if you were driving down the road and somebody like in a truck came up behind you and like started screaming at you to pull over, and then they gave you a ticket? You know, that would be weird, because who's supposed to do that? If you're doing, cops do that, right? Do they just drive around in normal cars? No, they wear a uniform, right? They wear a badge, so you know they're a cop, so you know they have a right to do that. Okay, well, in the same way, since there are some equations that are functions and some that are not, the ones that are functions get a special badge, so you know that they're not just any old equation, they're actually a function. And here it is. Did we decide this was a function? We did. Here is his badge. He's going to take off his civilian clothes, and he's going to put on his uniform.
Whoa.
And now we know he's a function. He's always a function. It's just now he's wearing his uniform. F of x is just another way to write y, but it's a way to write y so that we know that this is a function. That's it. Okay? Weird. It's weird, but that's how they do it. And it doesn't have to be f either. It could be g. Okay? There's different uniforms. There's Marines. There's Navy. All kinds of uniforms you could wear.
What happened to being a cop?
There's a nurse. I don't know. All right? All right, so this is what we call function notation. Function notation. Ready? I'm going to give you guys some facts about function notation. The way we identify which equation is a function is by replacing the y, the output, with an f of x. By the way, I don't know if I emphasized that enough. Let me back up a little bit here. The number that you plug in is called a input. The number that you get out is called a output. Okay. So, in the case of a y equals the square root of x, y is the output. That's the answer you get after you plug something in for x, right? So x is the input, y is the output. So we do this by replacing the output with f of x. Okay? That's its badge. So for instance, y equals 2x becomes f of x equals 2x. You guys good? That's it. It's just a badge. Don't read into it. For the notation, here's how we say it. You say f of x. That's the English way of saying that. So if I ask you guys to read that, you're not going to say f parentheses x parentheses. You're going to say f of x, right? All right. I judge you severely.
Why is it f of x and not just fx?
Because then they'll think you're talking about the television network.
What?
I'm joking. I don't know. I don't have a good answer for why they chose to write like that. Now, here's what's really irritating about this, and sometimes mathematicians do this in their notation. There's a few cases where they get confusing. Usually when you have one letter next to another one with parentheses, what does that mean you're doing with those things? Sure does, right? But in this case, it does not mean that, because f is not a number. Now, x is a variable, right? We're plugging numbers in for x. F is just a name. That's the uniform this function gets to wear. So this is only a name. You can't multiply Nathan by 2. That doesn't make sense. What's Nathan times 2? That's a name. 2 Nathan, sure. It's Nathan's not a quantity. Nathan is a person. So you can't, it's not f times x. This is f. And to make it worse, the way we read it is f of x. And when you read multiplication, what word do you usually use? Yeah. But it doesn't mean multiplication in this case. I'm so sorry I didn't invent it, but this is how they do it. Very confusing. It's not multiplication. All right, so it does not mean f times x, just so you know, because f is not a number. Next, it means that the function's name is f, and the input variable is x. The number we're plugging in for is x. That's what it means. It's not necessary to use the letters f or x. It could be anything. For instance, instead of y equals the square root of x, I could have had I could write y equals the square root of m. Who cares what variable you use, right? And then since that we already know this is a function, I could replace that y with a g if I wanted to and say g of m is equal to the square root of m. It still means this is a function whose name is g, and we're plugging numbers in for m. That's what that means. Okay? So that is function notation. Function notation continued. The expression f, how do I say this?
F of 3.
F of 3. So the expression f of 3 means that we plug 3 in for the input, which is usually x. And the result is what we get is the output.
So like white.
Yeah. So this means plug 3 into your equation. It does not mean f times 3. It means plug 3 into your function and see what you get. Okay? So let's do an example like that. Did I print example 1 for you?
Yes.
Okay. So here we go. G of x equals this. Huh. Is this a function? It is. How do you know? He's wearing his uniform. This is a function. What's this function's name?
Gilbert.
G.
Gilbert.
Yeah, Gilbert. All right. So I've got this function here. Which variable is my input variable? The one in parentheses?
X.
Okay, x is my input variable. So this thing says find g of 2, right? So what does that mean again?
Gilbert's going into X.
This means plug 2 in for which variable?
X.
X for the g function. So plug the 2 in for the x. So here we go. Here's g. I want you guys to write the whole g function all over again now. But instead of x, I want you guys to leave blanks there. You guys agree that the g function? It's just I took the x's out and put blanks. And what's going in the blanks? 2. Okay, now we're only going to work on this side. And you've got to know your PEMDAS.
And that's excuse me. Wait, excuse me.
Okay, parentheses. Is there anything to do inside the parenthesis? It's just a number. It's just 2. I can't do anything to 2. 2 is good. So I'm going to skip parentheses. And I'm going to go into exponents. Do I have exponents?
Yes.
Yes, I do. I'm going to box that. That's an exponent. So what's that?
2. Wait. Oh, 4.
It's 4. You guys don't have to show every step. I'm going to, just for the sake of my work. So there was no parenthesis work to do. Got the exponent taken care of. Do we have any multiplication? 3 times 2, right? What's that? -6. Okay, now do I have any division? No, so we'll skip that. Now, here's the unfortunate thing with addition and subtraction. Actually, the same thing applies to multiplication and division. You might think, well, m comes first, so I always multiply first and then I divide. That's not actually true. It's left to right. So as you look up here, you want to go left to right with your adding and subtracting. So what comes first? You're going to do that first, okay? So what's 4 minus 6?
-2 plus 5, and then that equals G2 equals 3.
And so we have g of 2 equals what?
3.
-2 and 5 makes 3, right? And there's your final answer.
Oh, that's it?
That's it.
Oh, wow, that's it.
Now somebody up here is somebody's gonna think, wait a minute, Mr. Bailey, we have 2 times g equals 3. We got to divide both sides by 2. And I'm gonna say, doesn't mean 2 times g. This means we have a function whose name is g, and we plugged 2 into it, and what we got out was 3. Okay, so this is my input, and this is my output. There's my answer. So, what do? You take this number, and you plug it into your function. You simplify using PEMDAS. Bueno?
Yeah.
All right. Your turn. Go. What'd you get for g of negative 2?
Ooh, the answer?
Yeah,
Negative 5.
-5 is right. So what we do is we take our g function and we plug 2 in for the x. 4 times -2 is -8, and -8 plus 3 is -5. All right, now we'll take a look at the second one here. Natalie, what did you get for the second one that I invented halfway through the problem? +7 is good. Now, it's if you got 36, if you got 31, you made the mistake that I wanted you fell into the trap I wanted you to fall in. So watch, I'll show you. So for this problem, what are we plugging in for x? What are we plugging in for x? 2. Now the trap that we fall into here is that a lot of people want to multiply these first, and they get 6, and then they square it, and then we get 36, right? But you don't multiply first. According to PEMDAS, what comes before multiplication? The exponents do. So you would do 3 times what? 4 minus 5, which is 12 minus 5, which is 7. So f of 2 is 7. So if I plug in 2, I get out 7. So as you guys can see, function notation is just plugging numbers in and getting answers, right? And notation. That's it. Knowing what this means. It means to plug a certain number in and get an answer. Gotta watch your order of operations to make sure you calculate it correctly, but other than that, we're good. All right? Can I proceed? Huh?
Hey.
Thought somebody said something. What? Did you need that? Sorry. There you go. We're going to transition a little bit here. Let's talk about 4 types of functions. We've already learned about one of them. Actually, 2 of them. Y equals a number. For example, like y equals 2. That's called a constant function. And you guys are going to want to write this picture. A constant function looks like this. Do you guys remember what this looks like when you graph it? Y equals 2? It's a horizontal line. So let's draw that. That's what a constant function looks like, just a horizontal line. All right? Here's another one, a linear function. Y equals x. What's the y-intercept for this? 0.
So it goes like this.
What's the slope?
1.
So it's rise 1, run 1. Linear functions look like diagonal lines. So constant functions look like horizontal lines. Linear functions look like diagonal lines. Now we'll get into some stranger things. Remember from our worksheet on Friday? What do these guys look like?
Oh, it's the opposite.
They look like a V. They look like a V. Absolute value functions look like a V.
V for victory.
Do you guys remember what x squareds look like from Algebra 1? It's a U-shape known as a parabola. So parabolas look like a U-shape. So here's what I want you guys to know. Constant functions look like horizontal lines. Linear functions look like diagonal lines. Absolute values look like V's, quadratics, or x squareds look like U's. Now, how can you tell what they are? By looking at the equation. That matters too. Well, if it's just y equals a number, that's a constant function. If it's y equals x to the first power, can you guys just put in like a little 1 there and circle it? Then that means it's linear. But if it's an absolute value, it looks like that. I'm circling the important parts here. And finally, what do you think how can you tell this is going to be a parabola? That guy. So Those are the characteristics. That's how you can tell what type of function they are. Okay? I'm about ready to put up a slide of different functions. Some are graphs, some are equations. And I'm going to ask you, is this a constant function, a linear function, a quadratic function, or an absolute value function? Okay? Can I erase?
Yeah.
Not yet? Yeah, Heidi? Here's your options. For each one of these, you're going to label it. You're going to name it as either constant, linear, absolute, or quadratic. Go for it. I'm going to pause and let you go. All right, here we go. Javier.
Don't do it yet.
Javier.
Don't do it yet.
What'd you put for this one?
Come on.
Huh? It is quadratic. How did you know that was quadratic? Because we're squaring the x, right? You might think, wait a minute, you're not squaring the x, you're squaring x minus 4. Well, the x is in there, right? So it's going to get squared. Alexis, what about number 2?
Snap, look at my paper. I'm so small.
It is an absolute value function because it looks like a v, right? All right, next, I'm going to ask, not here, Danielle. What about number 3?
It's a constant.
It is a constant function. All right, last one, Heidi. It is linear. It's an x to the first power, so that's linear. All right, so you guys now know how to classify functions. Okay, can you guys get out your cell phones for me? All right, now open your calculators up. Open up your calculators, and I want you guys to find the square root of 4. Now, I know you already know the answer without your calculator, but just humor me for a minute. You guys should get 2. The reason we're doing this is so that I know you know how to use your cell phones to find a square root appropriately. So can you use your phone to find the square root of 4 and prove that it's 2? So you push 2, right? And then you're going to find this button somewhere. Focus, guys, back there. John and Vanessa, you guys doing the exercise? You're supposed to be using your calculator. All right. So, here's what I want you guys to do next. I want you guys to find the square root of -4. That's right.
Look at it, because it's like it got the 2 to 3. That's weird. Internet your stuff.
Guys, some of you are still not looking up here, so I moved on to something new. I said, find me the square root of -4 on your calculator. What do you guys see?
I don't know how to answer the square root.
What does it say, Adrian?
Error.
It says error.
Mine says invalid.
It should say error. Okay, now why does it say error? The reason why is because there is no such thing as the square root of a negative number.
Hey, give this man a toy. He's about to break out.
All right. And Jonathan, I am feeling a little disrupted, so I'm going to ask you to stop disrupting the class right now. Vanessa as well. I'm trying to teach right now, okay? Okay, so my point here is that you guys can't plug anything that you want to in for x. You could plug in a lot of numbers, but you're not allowed to plug in what kind of numbers? If you plug in a negative, there's no answer. And by the way, do you guys remember the graph that we had? It looked like that, right? Over here, what kind of x's are these? Do you notice the graph doesn't exist on this side? Okay, so we're going to be talking about domain and range. Domain and range are what are the possible values of x and what are the possible values of y, because not all functions can have just anything be x or y. They're limited, like this one. It's only allowed to be positive x's. And by the way, you'll notice that the y's can only be positive also. There's no negative y values down there, is there? So you can never take the square root of something and get a negative out of it. That's not possible. So that's domain and range. So here we go. Domain is what we call all the possible values of x, or the input. Range is all the possible values of the y. Now we're going to be finding domain and range by looking at a graph. Okay? Now x goes which way on a graph? Left and right. Y goes up and down. So to find our domain, we're going to ask ourselves, how far to the left does our graph go? And how far to the right does our graph go? And x can be anything in between there. Okay? For range, it's going to be different. Instead of asking how far left and right, it's going to be how far up and down does our graph go? Because those are the possible values of y. All right? So, for instance, with this one here, the domain. Let's do x first. That's left and right. How far left does it go? Stops here, right? What's the x value there?
0.
How far right does it go? The arrow means forever. So the domain is anything from 0 up to infinity. Let's take a look at the range. Range is up and down. So what's the lowest point? It's this one again, right? And that's also 0. How far up does it go? Well, it's looking pretty flat, but we can assume it does keep going up. So they're actually the same. So basically, now this is just a fancy way of saying positive numbers from 0 to infinity. Don't you guys agree that's just positive numbers?
Yeah.
That's what that means. Oh, but let me ask you a question. Were we allowed to plug 0 into a square root?
No.
We did it earlier today. Remember when we made our table? We plugged in 0. What was the square root of 0? It works. So you know what we can do here? We can say it equals 0. You can't say it equals infinity, though, because you can't reach infinity. That's the concept. All right. So that's what we're going to be doing today. We're going to be finding the domain and the range, and you're going to find out what they are by looking how far left and right. That's your domain. How far up and down. Let's do a few examples just to kind of get that really well drilled into your mind. Here we go. I printed this for you, right?
Yep. We can barely see them.
All right, I'll tell you what they are, though. So, let's start with domain. For domain, what letter are we looking at? X.
And range is y.
That's correct. Now, for the one over here, we're looking how far left does the graph go? So you guys agree that this point is the point that's farthest to the left?
Yes, sir.
Okay, what x value is that?
3. -3.
Then over on the other side, we ask ourselves, how far to the right does our graph go?
0.
Would you guys be able to circle the dot that's furthest to the right?
-1.
You agree that that's the point that's farthest to the right, correct?
Oh, what?
All right, what's the x value for that point?
0.
You guys were right. It's 1.
Oh.
So x can be anything from -3
1.
all the way up to 1. See, can't x be here too?
Yeah.
But we're just saying x can be anything from here to here. So we just look at the endpoints, that's all. All right, let's do the y or the range now. Range is for the y values. What's the lowest point on this graph? -4. You guys agree that's the lowest point? Isn't this also, though? There's 2 of them. But that doesn't matter because they both have the same lowest point. What's the y value for both of those? It's -4. What's the highest y value? 0. So y can be anything from -4 to 0.
Whoa.
Okay? Stuff that I don't really care about, but I'm going to say it anyway. You guys ready? Closed dot means the point exists. So at this point, for -4 and also for 1, y can equal those things. Oops. X can equal 1 and y can equal -4. But over here, this is an open dot, which means you can't actually get there. It's like a hole in the graph. So x cannot actually equal -3, so we don't put an equal sign underneath. Okay? Now, can y equal 0?
Yeah.
Why? Because it can't equal 0 here, but it can right there.
Oh.
July. July. All right. So y can equal 0. I'm not too worried about the equal signs though for now. I just want to make sure you guys get the right, left, up, and down thing for today. But if you can do the other one, I'm cool with that. All right, let's do another one. Write in, or find this one.
Okay, so,
Well, that means
so
M
first
for the
this
third.
this way, right?
That's domain, and that's x, right? Range is this way, and that's y. All right, here we go. Nathaniel, I'm going to start with domain. What letter goes here?
X.
Well, you're not. Nathaniel, x goes here. Okay? I don't want to start with domain. I'm going to start with range. Because domain's a little weird looking on this one. I'm going to start with y. Okay, so range is the y value. So, Joanne, do you know what goes here? Look at your notes. And it says this is the number that is the highest point on your graph. What's the highest point on our graph? You guys agree it's here, right? So what's the y value for those points? It's 10. Does y actually touch those points?
I mean, it's
So we can say
very- it's
equals.
aligned, like,
Yeah, it's there. It touches it. Now, next question. What is the lowest point on this graph, Kenny? Kenneth. Good. So you're looking at the right thing, but now I'm going to twist it up a little bit for you. It's not a dot, it's an arrow. You know what that means?
Oh, infinite.
It keeps going down. So you were good. You're looking at the right spot. But since it's an arrow, we're going to say it's infinity. And since it's going down, what kind of infinity am I going to put?
Negative infinity.
That's what we. All that means is you're going down
There's
forever.
such thing.
Oh, I was like, what the freak? Does a 10 have to be on the right?
Yeah, bigger on the right. Now, if you wanted to flip these signs around, you could reverse the numbers too, because this means greater than. So y is greater than negative infinity, and 10 is greater than y. But basically what this just means is y can be anything from negative infinity all the way up to 10. So you could have any y value from down there up to there, and then it stops. All right, I don't like the domain on this one. It's confusing, okay? So let me help you out a little bit. It starts here in the middle, right? And you guys agree that it's spreading out?
Yeah.
Those x's are spreading out, aren't they? Now they're slowing down, but they still keep spreading out more and more to the right and left as we go. Is it ever going to stop spreading out? Well, according to our arrows, there's no reason for us to assume it's going to change. So how far to the left is this thing going to go?
Infinite.
Infinity. And how far to the right?
Beyond.
Infinity. Remember,
Was
left
it negative?
left and down are negatives, right and up are positives. So now this is really just a fancy way of saying what? If x can be anything from negative infinity to positive infinity, then x can be all real numbers. So you could just say all real numbers for this if you wanted to. I'll write it. All real numbers. But you don't have to. You could write it like that. I'll give you full credit. Okay? But it just means x can be anything. All right, let's do another one.
Hang on.
So anytime you've got arrows, you've got infinities, and you can assume if it's going down, it's going to keep going down. If it's widening out or spreading out horizontally, you can assume it keeps doing that, so on and so forth. All right. So no, this is fine.
Oh.
All right. I want you guys to do the domain first. Go. Do your domain. Do the domain. You can. But there's your domain. So x could be anything from negative infinity up to 5, and range could be anything from negative infinity up to 2. The highest point is 2, and the furthest point to the right is 5. All right. So now we got some student practice, which means you're doing it completely on your own. I mean, you could work with other people if you want to. See if you can get these answers. Find the domain and range for each one of these functions. All right, there you guys go.
Wait, why is there only